Okay, our next lesson here is Unit 4, Lesson number 2, and we are solving quadratics by factoring. So we have 4 steps to do this. Our first step says right here that we want to move all terms to one side and set the equation equal to 0. Now, why do we want to do that? Let's talk about that real quick before we get into solving these examples. So over here on the right side of the screen, you should see that I've drawn in a coordinate system. We've got the x and the y axis. A quadratic, now that's a parabola of some sort. And you have to remember that the solutions are where the parabola or quadratic crosses the x-axis. Now usually we would say that the equation would look like, we're in the form y equals ax squared plus bx plus c. The quadratic is set equal to y. Now, if we want to find the solutions, you can graph it, and then you could get the visual of where this parabola is crossing the x-axis in up to 2 places. Or, algebraically, we set the equation equal to 0, and that 0 is replacing the y. And when the y value is 0, we stay on the x-axis. Okay, so we're saying that the y value basically is 0. And when we solve for x, again, algebraically, that's going to show where our quadratic would cross the x-axis without ever having to graph this equation. So step 1, move all terms to one side, set the equation equal to 0. Step 2, we're going to factor. Now we know different types of factoring, and we have to be able to recognize which type of factoring needs to be applied. Step 3, after we factor, each factor gets set equal to 0 itself, and we solve for the x value. So we're going to write our answer as a solution set. X equals, and then we put our 2x answers in braces, just like we did on 4.1 part A, where we were finding the solutions by graphing. So let's look at number 1. Our equation is x squared plus 9x equals 0. Step 1's already done. This equation is already set equal to 0. So step 2, we're going to factor. Okay, I have an x squared and a 9x. There's only 2 terms, so we can't do 1, 2, 3 factor tree. But the first thing you should always look for, no matter what type of factoring you're doing, is a GCF. Is there a certain number or an amount of terms that we can pull out of the polynomial given? And I notice that they both have x. Okay, there's no number that I could take out, but because the coefficient of x squared is 1, but I can take an x out of each of these terms. So I'm going to divide an x out. Okay, that will result in 1x, and then 9x divided by x is just 9. Remember, when you divide out a GCF, what we get when we divide it, that goes in parentheses, and that GCF of x goes on the outside of the parentheses. And remember, this is all set equal to 0 right now. Now, what we have here are 2 separate factors. X is a factor, and then x plus 9 is a factor. Those are the 2 components that get multiplied or factors to make x squared plus 9x. So we've done step 2. Step 3, set each factor equal to 0 and solve for each x value. So we're going to call this t-bar. Okay, I'm going to make almost like it's going to look like a t. I'm going to make a t-bar to separate my 2 factors, and I will set each of these 2 parts equal to 0. We had an x, that gets set equal to 0, and I'm going to set x plus 9 equal to 0. And we're solving each of these for x. Now notice here on the left side, x equals 0 is already solved for. That is one of our solutions. That's one of the values where our parabola is crossing the x-axis. And then I have x plus 9 equals 0. So to solve this, we would subtract 9 from each side, and we get x equals -9. Okay, those are my 2 solutions, and technically we write these in braces. I would say -9, comma 0. Usually go lowest to greatest. Okay, again, that represents, if I had a parabola, here's 0 for x, maybe here's -9, and I would know that this parabola is crossing, it's doing something similar to this. Okay, rough sketch. Okay, so 2 places where it would cross the x-axis. Okay, looking at number 2, we have 4x squared minus 8x equals 0. So again, step 1 is done. This is already set equal to 0. Now we need to factor. Again, there's only 2 terms. We can't do our factor tree or our slide divide bottoms up, none of that business, and they're not both perfect squares. So we're going to take out a GCF. Out of 4 and 8, okay, the largest factor or the biggest number that can go into both of them is 4. And we have 2 x's and 1 x, we can take out 1 x. So we're dividing that out of each factor. So 4x squared divided by 4x is 1x. Then negative 8x divided by 4x is negative 2. So x minus 2 goes in the parentheses, 4x goes on the outside. And this is all still set equal to 0. Again, I have these two separate factors. Okay, 4x is a factor and x minus 2 is a factor. So I t-bar in between them. Okay, I draw that, keep messing that up. I draw that t-bar in between, and then each of these factors gets set equal to 0. So 4x is equal to 0, x minus 2 equals 0. And we solve for x. Now, 4 times what makes 0? Well, you would find that out by dividing by 4 if you really needed to. But 0 divided by anything is 0. So that's another one of our solutions. X minus 2 equals 0. To get the x isolated or solved for, we would add 2 to both sides. So we get x equals 2. So to write our two solutions, we have x is equal to, in braces, 0, 2. This parabola is crossing the x-axis, again, at 0, and then positive 2, doing something like this. Okay, not to scale, just a rough sketch. Okay, on number 3, we are solving for x squared minus 4 equals 0. So we've done step 1 already. It's been done for us. It's equal to 0. Step 2, we need to factor this. Now factoring, I'm checking for a GCF first. Is there a greatest common factor if I have x squared and negative 4? Okay, now x squared does not have a coefficient and negative 4 doesn't have any x's. They have nothing in common. So there's no GCF. And I also notice that there's only 2 terms. So remember, I can't do 1, 2, 3 factor tree to factor this. So what we're left with is difference of squares. And I do have that situation. I have x squared is a perfect square, negative 4 is a perfect square, and we have this minus sign in between. So to do difference of squares factoring, remember we make 2 sets of parentheses. We put opposite signs in the middle of each set of parentheses, and then to get what goes in here, we're taking square roots of the polynomial we're factoring. I'm taking the square root of x squared. The square root of x squared, to get x squared, that's x times x. Okay, so 1x goes in each set of parentheses. The square root of 4, that's made up of 2 times 2. So we're putting positive 2 in each set. And this is all set equal to 0. To finish this off now, we have 2 separate factors. It looks a little bit different. When you take out a GCF, remember that looks like distributive property. When we factor with these other methods, we've got a FOIL situation, okay? But these are each 2 separate factors. So I t-bar in between these 2 separate factors like so. I'm setting x plus 2 equal to 0, and I'm setting x minus 2 equal to 0 and solving for x. So that means on the left side, we're subtracting 2 from both sides. Excuse me. There we go. And we get x equals negative 2. On the right side, we are adding 2 to both sides to isolate x, and we get x equals positive 2. So to write these solutions, we would say x is equal to both negative 2 and positive 2. Or another way you'll see it expressed would be like this. X is equal to, you could put plus or minus 2. Same number, but with opposite signs. Both are acceptable answers. Okay, on number 4, we have 9x squared minus 25 equals 0. So it's already set equal to 0. Again, that needs to happen. I am looking, do I have a GCF? Okay, is there a number that goes in, besides 1, that goes into both 9 and 25? And there's not. Okay, now I have x squared by the 9 coefficient, but I do not have any x's in 25. Again, so there's no GCF at all. It's not 1, 2, 3 factor tree. So again, it's still difference of squares. 9x squared is a perfect square, and so is 25. If you don't know your perfect squares, you're going to have to test that out in a calculator. But it is something that we probably should know by the time we're juniors, what perfect squares are. Any number times its own self. Okay, so 2 sets of parentheses were equal to 0. One set has a plus sign in the middle, one has a minus sign. How do we get the terms that go in? We take square roots. The square root of 9x squared, the square root of 9 is 3. The square root of x squared is x. So 3x goes in each set. And then to get the second term in each set of parentheses, we take the square root of 25. That's 5. So we're putting in a 5 here and here. So factored, it is 3x plus 5 times 3x minus 5. Okay, I separate the two factors by t-barring it. Each of these factors gets set equal to 0. So 3x plus 5 equals 0, 3x minus 5 equals 0. Now solving for x, notice that we have a coefficient in front of x. That means that we aren't just getting the opposite of what we had like before, because when I subtract 5 from both sides on this first one, we get 3x equals negative 5, but now I have to divide both sides by 3. So we get, for one answer, x equals negative 5/3, and for my next solution, we kind of follow those same steps, but we're going to get an answer with the opposite sign. We're adding 5 to both sides so that we have 3x equals positive 5, and then divide by 3. So our second answer is positive 5/3. So when you find a solution and the factoring is difference of squares, you're going to get almost the same solution, but they have opposite signs. We have negative 5/3 and positive 5/3, and that happens when you do difference of squares method. Okay, or you could say plus or minus 5/3. Okay, number 5, and I apologize if this is a little blurry. I'm not sure quite what happened to it, but hopefully you can still see good enough, and you should have a copy of the notes even if you're just watching this that you had available to print out. On number 5, we have the polynomial or the quadratic trinomial x squared minus 10x plus 21 equals 0. So step 1 is done. It's set equal to 0. Now we need to factor it. So I'm looking, how many terms do I have? I have 1, 2, 3. We can do our factor tree. And I'm checking in front of x squared first. There's no value in front of our x squared, so there's nothing here to factor out as a GCF. We're just going to jump into our factor tree. The factor tree is always coming out of the constant, 21, and we have to add these two factors that we're looking for, these two numbers. They have to multiply to positive 21 and add to negative 10. So we're thinking about what that could be. What multiplies to 21? The first thing I think of is 7 times 3. So 7 and 3. But while 7 and 3 multiply to positive 21, they don't add to negative 10, but I know that two negatives make a positive when we multiply. And then it's still adding in the same way, but they stay negative. So this multiplies to positive 21, adds to negative 10. So now I'm going to put them in parentheses here. Again, it should look like a FOIL problem when we FOIL or factor a factor tree problem. And we had x squared as our leading term. Remember, we get x squared by saying x times x. So 1x goes in each set of parentheses. And then we drop in those two factors. We had negative 7 and negative 3. It's still set equal to 0. Now we're going to set each of these factors equal to 0. So we're t-barring it. So we're saying x minus 7 equals 0 and x minus 3 equals 0. Okay, to solve each of these, if I add 7 to both sides, I'm going to get x equals positive 7. Add 3 to both sides, we get x equals positive 3. So our two solutions are 3 and 7. Okay, number 6, we have another quadratic trinomial here. We have 2x squared minus 2x minus 24 equals 0. Okay, it is a 1, 2, 3 factor tree situation, but I have to check in front of x squared before I do any factor tree. Because I have that 2 as a coefficient of x squared, we can't do a factor tree yet. First, I check, will it come out as a greatest common factor? Does 2 go into all 3 terms? And it does. So we need to divide it out first. Otherwise, we can't do our factoring. So we have, let's see, my pen's not working. Here we go. Positive x squared, and then negative 2x divided by 2 is negative 1x, and negative 24 divided by 2 is negative 12. Now, don't forget that when we factor something out as a GCF, what we get after we divide by the GCF goes in the parentheses, and the GCF itself goes on the outside. So now that this x squared has nothing directly in front of it, has no coefficient right now, we can do our factor tree. So that comes out of negative 12. We're looking for two numbers that multiply to negative 12, and when they add up, they add to negative 1. So I'm thinking what multiplies to 12 and adds to negative 1, which two factors are just like 1 away from each other, and I'm going to say that would be negative 4 and positive 3. Okay, again, they multiply to negative 12. Negative 4 plus 3 is also negative 1. It fits our puzzle both ways. So we're going to drop this down into factored form. We have 2 times x minus 4 times x plus 3, and this is all equal to 0. Now technically we have 3 sets of factors here, right? 2 is a factor, x minus 4 is a factor, x plus 3 is a factor. We set each of our factors equal to 0. So if I set 2 equal to 0, notice there's no x left to solve for. If there was an x that we had factored out, that would give us another solution. But right now, that does nothing. That does not give us an answer, again, because there is no x to solve for. If I have x minus 4 equals 0, I would add 4 to both sides, and we get x equals positive 4. We set x plus 3 equal to 0. We subtract 3 from both sides, and we get x equals negative 3. One thing to keep in mind, that a parabola can at most cross the x-axis 2 times. So at most, we can only get 2 answers. We can't get more than 2 answers at this point. That won't be until we do cubics and other types of polynomials that have higher exponents. So our solution is x is equal to negative 3 and positive 4. Okay, on number 7, we are factoring 3x squared minus 13x minus 30. So I do notice that this is a 1, 2, 3 term, so 1, 2, 3 factor tree, but before I start that, I'm checking that in front of x squared, I have this 3. Again, you can't do factor tree when there's a number in front of x squared other than 1. Okay, it kind of blocks our access. So then we check, does 3 come out as a GCF? Can it divide evenly into all 3 terms? Well, 3 can go into its own self 3, and it can go into 30. It cannot go into 13. 13's prime. So because it does not divide out as a GCF, this is now a slider. So sliders where we have to take that front number, we slide and multiply it to the c value. When I slide it over, it removes it from being in front of x squared. So now we have x squared minus 13x minus 3 times negative 30, which is negative 90. And this is equal to 0. So now we're going to do our factor tree to negative 90, 2 numbers that multiply to negative 90 and add to negative 13. Again, because this is a video, I'm not going to take the time to talk about trial and error. I just already know what these are. These 2 factors are negative 18 and positive 5. They multiply to negative 90. They add to negative 13. So we're going to put them in the parentheses. Okay, just like this. Still set equal to 0. We're going to say we have x minus 18 in as one factor and x plus 5 as the other. But don't forget, when you are doing a slider, it's slide, then we factor, then we divide, and then we divide by the number that was slid over. We're dividing each of these factors by 3. So then we do simplify. Negative 18 divided by 3, we have x minus 6. Okay, 18 divided by 3 is 6. And then 5/3 doesn't simplify, so we say bottoms up. So this one is 3x plus 5. And I will show a shortcut with this here in a minute. And now we got to t-bar this thing so we can get our solutions. My 2 factors each get set equal to 0. We're saying x minus 6 equals 0 and 3x plus 5 equals 0. To solve on the left, we would add 6 to both sides. So we were going to say our first solution is x equals positive 6. On my next side here, 3x plus 5 equals 0, we would minus 5 to get it to the opposite side so that we have 3x equals negative 5, and then we divide by 3 to both sides, so x equals negative 5/3. Our 2 solutions, I'm just going to write it down here, are x equals negative 5/3 and positive 6. And braces. And it's just hard to write on the screen, so they look terrible, but that's okay. Now notice, before we did bottoms up, we had a positive 5/3. We did bottoms up, we got 3x plus 5, but then we ended up going back to factoring. We got back to negative 5/3. So if you are only factoring and that's the end of the problem is to leave it in parentheses, to leave it in factored form, you have to do bottoms up, okay? I would need the solution to look like this. But if you're finding the solution, if you're solving for x, like you have to t-bar it, you can kind of skip the bottoms up section because it's going to go back to that same fraction that we had above. So it's kind of, I don't know, I feel like it's just extra work and it's not really necessary. So again, if you're leaving it in factored form, do bottoms up. If you're solving it for x, just leave it as a fraction and it'll end up being just the opposite sign of what it was in the parentheses in factored form. We'll talk about that more as we go on. Number 8, we have 6x squared plus 5x minus 4. So again, a 1, 2, 3 factor tree situation, but we've got this 6 in front of x squared. So can 6 or part of 6 come out as a GCF? And this 5 here in the middle, he's prime. So no part of 6 can come out, no factor of 6. So it's a slider again. We're going to slide and multiply it to -4. So this will result in x squared plus 5x minus 6 times 4 is 24. And that's equal to 0. Now we're going to do 1, 2, 3 factor tree. What multiplies to -24 but adds to +5? This is going to be, let's see, 8 and -3. Yes, that's going to work out nicely. Multiplies to -24, but then adds across to 5. So in factored form, it will look like x plus 8 times x minus 3. So that was the factoring. We did the slide, now we have to divide. We divide by the number we slid. We're dividing by 6 to both of those factors. And we don't need to do bottoms up, but we still have to simplify. Every fraction should always be checked for simplifying. What does 8/6 simplify to? Well, that simplifies to 4/3. So I would say this is x plus 4/3. And 3/6 simplifies to 1/2. So x minus 1/2. Now I'm not going to do bottoms up. That's what I was talking about before. If I brought the 3 up in front of x and the 2 up in front of x, I could, but it's just going to bring me extra work later. So I'm going to say this is x plus 4/3 equals 0 and x minus 1/2 equals 0. To solve for x on each, we're doing opposite operations. We're going to get x equals -4/3 and x equals +1/2. Those are our two solutions. We would write it as a solution set of -4/3, 1/2 in braces. Ta-da! So now we're on the back side of our notes, and on this back side, we're going to have the extra step of moving all terms to one side so that the equation is set equal to 0. Previous examples to this, our equation was already set equal to 0. So on number 9, we have 2x squared equals 5x. Again, we need all terms on the same side. I like to move all terms to the left because I like my 0 to be on the right side of the equal sign. Doesn't have to be, but it just kind of works out nicer. So we're subtracting 5x to both sides so that our equation is in the form 2x squared minus 5x equals 0. Okay, that was doing step 1. That didn't have to be done before. Now we're going to factor. I only have 2 terms. So I'm checking first. Do I have a greatest common factor? I can't, my 2 numbers here are 2 and 5, so no number can be divided out of 2 and 5, but they both have x's. So I can take an x, one x out of each term. If I have 2 here and just 1, we can only take out 1. So 2x squared taking away an x is 2x. Negative 5x taking away that x is -5. Again, wrap it in parentheses because that's what we do when we take out a GCF. And the number we divided by, that GCF goes on the outside of the parentheses. It's equal to 0. So again, it looks like a distributive property problem. I still have 2 factors. X is a factor, and then 2x minus 5 is a factor. So I t-bar in between. Okay, your x's are always on like either side of that t-bar. We're going to set each of these factors equal to 0. X equals 0. 2x minus 5 equals 0. On the left side, x equals 0 is already solved for. 2x minus 5, we're going to add 5 to both sides so that we get 2x equals 5, and then divide by 2. We don't do decimals here. We just leave it as an improper fraction. So our 2 solutions are for x, 0 and 5/2. And that's done. Okay, number 10, we have 7x squared plus 8x equals x squared. So this x squared here on the right, we need to move it to the left side of the equal sign. So I'm going to subtract x squared. And notice it's an x squared, so it can combine with the 7x squared. They're like terms. So 7x squared minus 1x squared is 6x squared. Remember, if it doesn't have a coefficient, it's like there's an implied 1 there. Don't forget that. Plus 8x, and this is equal to 0. Okay, now that it's set equal to 0, we're going to factor. So what type of factoring? Again, I only have 2 terms, so not 1, 2, 3 factor tree. Do they have anything in common? Okay, my numbers are 6 and 8. They're both even. So anytime you're dealing with all even numbers, you will have a number part to your GCF because they are at least all divisible by 2. All even numbers are divisible by 2. And that is the highest number that goes into both. Then check your x's. We have 2 x's and 1 x. We can take out 1, the smaller of those 2 choices. So we have to divide that out. 6 divided by 2 is 3. 2 x's take away 1 x is 1 x. 8 divided by 2 is 4, and x take away x, we're done with x's. So wrap it up, put that GCF on the outside of the parentheses, and this is equal to 0. Now we're going to separate our 2 factors and set them equal to 0 by t-barring. So we have 2x equals 0 and 3x plus 4 equals 0. To finish, we solve each of these for x. So on the left, we're just dividing by 2, and 0 divided by 2 is 0. Now, what's cool here, whenever you pull, like just factor by doing a GCF, and you get an x term of some sort on the outside, okay, there's no parentheses around any of this, you get 0 as an answer. Kind of a little shortcut once you come to recognize that. On the right side, for 3x plus 4 equals 0, we're subtracting 4 from both sides so that we have 3x equals negative 4, and divide both sides by 3. So our next solution is x equals negative 4/3. So x is equal to negative 4/3, comma 0. Okay, on number 11, we have 2x squared minus 50 equals x squared minus 1. So this equation is not set equal to 0 yet, so that's our first job. Okay, here's my equal sign. I'm moving everything from the right side to the left side of the equation. So I'm going to subtract x squared, and it matches up when I subtract it with the 2x squared. And we're going to get 2x squared minus x squared is just 1x squared. I also need to move this negative 1, and I will use its opposite operation. I'm going to add it, and it's a constant. It matches up with the constant on the left side of the equal sign. So negative 50 plus 1 is negative 49, and it's all equal to 0. Now, I need to factor now that it's set equal to 0. I have 2 terms, okay, x squared and minus 49. There is no GCF here. We're not doing 1, 2, 3 factor tree. This is a difference of squares, 2 perfect squares with that minus sign in between. So we get to make 2 sets of parentheses because this is the method. We put opposite signs in the middle of each set of parentheses, and we're taking square roots to get the values that go inside. The square root of x squared is x. Because of that, we put 1x in each set. The square root of 49 is 7 because it's made up of 7 times 7. So a 7 goes in each set. We have x plus 7 times x minus 7. Those are my 2 factors. We t-bar these 2 factors now so that we can separate them and solve for x. If we have x plus 7 equals 0, x minus 7 equals 0. On the left, we would subtract 7 from both sides, so we get x equals negative 7. On the right, we would add 7 to both sides to move it, so we would get x equals positive 7. Our 2 solutions here are negative 7 and positive 7 for x. Number 12, we have 3x squared equals 81 minus x squared. So the first thing we're going to do, okay, here's my equal sign, and we need to move all terms to the left side. So I'm going to add x squared. It will match up with 3x squared. And I'm going to also subtract 81. And 81 doesn't have anybody to match up with. So I'm just kind of going to stick them there for now. 3x squared plus 1x squared is 4x squared. 0, basically, minus 81. It's going to stay negative 81. Now this is all equal to 0. Now that it's set equal to 0, we can factor. Okay, I'm checking, do I have a GCF? Is there a number that goes into both 4 and 81? And there's not. Okay, they don't both share x squared, so no GCF these are, again, a difference of squares situation because I have two perfect squares with that minus sign in between. So again, two sets of parentheses, plus sign in one, minus sign in the other. What is the square root? What two terms times their own self, okay, two identical terms make 4x squared. And again, that would be 2x times 2x. So we have to break them apart. Each set of parentheses gets a 2x. The square root of 81, that's made up of 9 times 9. So we put a 9 in each set of parentheses. So factored, it's 2x plus 9 times 2x minus 9. And now we t-bar these two factors. We're setting them each equal to 0 and solving for x. So we're going to get, let's see, on the left we would have to minus 9 to both sides so that we have 2x equals negative 9. And then divide both sides by 2. So one solution is x equals negative 9/2. On the right, we would add 9 to both sides so that we get 2x equals 9, and then we would divide both sides by 2, so we get positive 9/2. I like doing difference of squares. Again, you'll notice the same answer, but with opposite signs. Okay, negative 9/2, positive 9/2. Okay, number 13, we have x squared plus 2x equals 80. So because it didn't say equal to 0, that's my first job. This positive 80, it needs to move to the left side of the equal sign. So we will subtract it over. I'm going to rewrite the problem in order so that it's x squared plus 2x minus 80 equals 0. Okay, count how many terms. I have 1, 2, 3. We're doing our factor tree. It's coming out of negative 80. So we're looking for two numbers that multiply to negative 80 and add to positive 2. Okay, because it's adding to 2 and we're multiplying to negative 80, okay, subtracting. I know that these two factors have to be somewhat close together. I'm going to think, because it ends in 0, it's a factor of 10. So I'm thinking 8 and 10. One has to be positive, one has to be negative. So I'm going to say this is a negative 8 and a positive 10 so that it adds to positive 2. They multiply to negative 80. So two sets of parentheses. Okay, because it was x squared, remember x squared is made up of x times x. So 1x goes in each set. We break those apart. We're dropping in negative 8 and positive 10. This is all set equal to 0. I have my two factors, so now we separate them by t-barring them. We set each of these factors equal to 0, and a lot of kids don't need to really rewrite this because you already know what the two answers can be. You can see it. Okay, that's some mental math right now, and that's okay. We get x equals positive 8 and x equals negative 10. So we write that as a solution set in braces, negative 10 and positive 8. If you don't write at least to greatest, you wouldn't be marked wrong. It's just the proper way to do it. Okay, on number 14, we have x squared plus 11x plus 29 equals x plus 4. So there's my equal sign. It's not, again, we need it to say 0 here on the right side. So we have to move the x and the positive 4. We're going to subtract x, and it matches up with the 11x. You have to find those like terms. And then we have this positive 4. We would need to subtract it, and it would match up with 29. So what do we get? We get x squared, and then we have 11x minus 1x is 10x. And then 29 minus 4 is a positive 25. This all equals 0. So our next step is to factor it. So again, I'm looking at how many terms I have to help me decide how to factor it. I have 1, 2, 3. We're going to use our factor tree. We're seeing what numbers multiply to 25 and add to 10. Well, I know that really the only things that multiply to 25 are 5 times 5. 5 times 5 make 25, and 5 plus 5 make positive 10. So, two sets of parentheses. Because again, we're dealing with x's, that's x times x makes x squared, so we put 1x in each set. They each get positive 5. Okay, notice they're identical. Let's talk about what happens here. There's still two separate factors. We're setting each of these equal to 0 and solving for x. So we're going to get, for each of these, we're subtracting 5, and we get x equals negative 5 on the left. We would have to subtract 5 from both sides here on the right, and we get x equals negative 5 again. We get two of the same answers. So what's our solution set here? We're going to say not negative 5, negative 5. We don't list the same x value twice. We already listed it. We just list it one time. But why what does this mean? Okay, we'll talk about this. We talked about it before probably, but what that means when you get the same value for x twice as a solution, think about how this relates to graphing. Again, all of these answers we get for x are showing where the parabola would cross the x-axis. You can't cross through -5 2 times. What's happening is that our vertex is resting where x is -5 on the x-axis. So our vertex, the x value of the vertex, it's -5 0 here. So that's what's happening when you get the same number for x 2 times. Okay, for number 15, we have 2x squared minus 9x minus 65 is equal to x squared minus x. So here's my equal sign. Whoops, right here. Okay, we don't have 0 here on the right, so we need to move everything so that we have 0 things left. We're going to subtract x squared from both sides, and then we're also going to add the x. We use opposite operations to move to the opposite side of the equal sign. 2x squared minus 1x squared is 1x squared. Negative 9x plus 1x is negative 8x, and negative 65 is not changing. We just bring it down. So we're dealing with x squared minus 8x minus 65 equals 0. So I'm counting again to help me decide what type of factoring. I have 1, 2, 3. We're going to use our factor tree. What multiplies to negative 65 and adds to negative 8? Again, when you're looking at a negative C value, then you know that you have a positive and a negative number you're dealing with. These two factors are going to be negative 13 and positive 5. Again, a negative times a positive, those multiply to negative 65. Negative 13 plus 5 is also negative 8. So we have in parentheses, again, to get x squared, we would have x times x, and we put negative 13 in one and positive 5 in the other. This is all equal to 0. We set our two factors each equal to 0. Okay, we're going to t-bar this, and a little shortcut. You can already see if we have x minus 13 equal to 0, we're going to get x equals positive 13 as one of our solutions. If we have x plus 5 equals 0, we would subtract 5 to both sides to get x equals negative 5. And I'm fine if you kind of take that shortcut and don't rewrite things. That's some mental math right there. X is equal to negative 5 and positive 13. On number 16, we've got 4x squared plus 41x plus 98 equals 2 minus 3x. So again, I need 0 things to be over here on the right side. So we're moving everything so that there's 0 things left. We're going to minus 2, matches up with 98, and we're going to add 3x, which matches up with 41x. What do we get when we put those together? We get 4x squared unchanged. 41 plus 3 is 44x, and 98 minus 2 is 96, and that's equal to 0. Okay, now I do have 1, 2, 3. We want to do factor tree, but I can't until the 4 in front of x squared is gone. Okay, that's just the rule. Check first, before you do a slider, check to see, does it come out as a GCF? Can 4 goes into itself, 4 goes into 44, and 4 does go into 96. You would need to maybe divide that because it's a larger number, but it does go into 96 24 times. Okay, so we're dividing all of these 3 terms by 4. Again, we get x squared plus 11x. 44 divided by 4 is 11, and 96 again divided by 4 is 24. In parentheses with that 4 on the outside. Okay, that was one type of factoring, so it's kind of unfortunate. I know it feels like a lot of extra work, but sometimes we have to do 2 different types of factoring. We took out a GCF, and now we're going to do 1, 2, 3 factor tree. What are the 2 numbers that multiply to 24 and add to 11? Okay, because we have to get these x's by themselves to get them solved for. You have to get rid of that squared by the x. So the 2 numbers that multiply to 24 and add to 11 are 8 and 3. So we have 4 times x plus 8 times x plus 3. This is all equal to 0. We set each of our factors equal to 0. If I say 4 equals 0, there's no x left to solve for, so that gives me no answer. If I have x plus 8 equals 0, we get x equals negative 8 because we subtract 8 from both sides. If we have x plus 3 equals 0, we would subtract 3 and get x equals negative 3. So our 2 solutions are x equals negative 8, comma, negative 3 in braces, not parentheses. because it's a solution set. They're both answers for x, not an x and a y value. That's what it would mean if we used parentheses. All right, our last two examples on this lesson. We have 2x squared plus equals x plus 21. So again, it has to be set equal to 0. So I'm going to subtract x. Doesn't match up with anyone, but I also need to subtract 21. You should always move everything to where your x squared value would be positive. Even though the right side had 2 terms, like more than what was on the left, I want to leave the x squared value positive. Otherwise, I'd have to factor out a negative, and it just makes everything messy. Okay, so this comes out to be 2x squared minus x minus 21 equals 0. And I'm going to hold up because I noticed that even though there's 1, 2, 3 for factored tree, I've got a 2 in front of x squared. Does 2 come out as a GCF? 2 does not go into 21 or 1. So when it does not come out as a GCF, that number in front of x squared, it becomes a slider problem. We slide and multiply it to our last value. So now it is x squared minus 1x, and 2 times negative 21 is negative 42. And this is equal to 0. So now we are able to do our factor tree because now I don't have anything in front of x squared. Well, it multiplies to negative 42 and adds to negative 1. This is going to be negative 7 and positive 6. So we write that in factored form as x minus 7 times x plus 6, and it all equals 0. I can't t-bar yet. You have to just really remind yourself that if you slide, you have to divide. Divide by the slider. We're dividing by 2. And then you have to check for simplifying fractions, or just to whole numbers. Negative 7/2 does not simplify, but 6 over 2 simplifies to positive 3. So I'm just going to cross out 6 over 2 and put 3. Now we're ready to t-bar between our two factors. And I'm not doing bottoms up again because when you have a fraction and you want to solve, it goes back to being the same fraction we had before, but just with the opposite sign. So redundant. So we have x minus 7/2 equals 0, x plus 3 equals 0, and solving for x, we get x equals positive 7/2 and x equals negative 3. So those are our two answers. Okay, last one, number 18. We have 4x squared minus 11x equals x minus 9. So we need to subtract x from both sides, and he will match up with the negative 11x. We're also going to add 9 to both sides. He doesn't really have anywhere to match up with, so I'm just going to kind of write him as a floater for now. So this gives us 4x squared. Negative 11x minus x is negative 12x, and then plus 9 equals 0. So there are 3 terms for factor tree, but we have this 4 in front of x squared. I would check, does 4 come out as a GCF? 4 goes into itself, 4 goes into 12, but 4 does not go into 9. So if it doesn't go into all 3, it cannot be the greatest common factor because it's not common to all. So we're going to make this a slider as well. We're going to slide 4 and multiply it to the c value, okay, and rewrite this as x squared minus 12x, and 9 times 4 is 36. This is set equal to 0. So now we factor. We're saying what multiplies to positive 36 and adds to negative 12. Well, negative 6 and negative 6. So writing this in factored form, it's x minus 6 times x minus 6 equals 0. But before we t-bar, if we slide, we must divide. So we're dividing by 4. Okay, now 6/4, we have to simplify as well. 6 over 4 simplifies to 3/2. So I'm just going to cross it out so I don't rewrite the whole problem. And now I'm going to t-bar. Okay, if I have x minus 3/2 equals 0 on both sides, to solve for x, we would just end up adding 3/2 to both sides. So we get x equals positive 3/2 and x equals positive 3/2. Again, when you get that identical answer for both, okay, notice they don't have opposite sides. That means our vertex was resting on the x-axis. So x equals positive 3/2 in braces. Just written one time. Now, again, factoring, you'll get better at it the more you practice. Count how many terms. If there's 2 terms, it's a GCF situation, and or it could be a difference of square situation. So recognize your perfect squares. If there's 3, you're going to do your factor tree, but it could also mean that there's a GCF in there, or it could be a slider if you have a number larger than 1 in front of your x squared value. So just remember all those tips and tricks. Factor, t-bar, solve for x.